Welcome to a walkSTEM on Nantucket Island. Here, we'll discover how physics principles can be explored in daily life. Our first stop is Siasconset Playground, long a favorite with Nantucket kids. Here, we'll discover an example of periodic motion. Let's head over to the monkey bars. If a child swinging on the monkey bars were taller, why would he swing back and forth more slowly? To answer this question, we can represent the child as a physical pendulum in the form of a long, thin rod with uniform mass, allowing us to use the two equations in red. First, the equation for the period t of a physical pendulum, or the time it takes the child to swing backwards and forwards once, and second, the equation for the inertia I of a long, thin rod. Although this is an oversimplification of the form of a child, combining these two equations allows us to relate L, the height of the child, to T, the period of the child. From this derived equation, written in blue, it is evident that if L is greater, or if the child is taller, the time T it takes the child to swing backwards and forwards once will be larger. Our second stop is the Siasconset Casino Association, known for its red and green clay tennis courts. Here we can find an example of impulse. Our question for this location is, why does hitting the ball too hard make it fly over the fence? When you hit a tennis ball with your tennis racket, you apply an impulse. The value of this impulse depends on both the force exerted on the object and the amount of time the force is in contact with the object. The larger an impulse applied, the larger the change in its linear momentum. With a larger application of force, such as a violent stroke with your tennis racket, the impulse and therefore change in linear momentum will be large, and there's a high chance that your ball will fly off your racket strings and right over the fence. Our final stop on our tour is Siasconset Beach, a favorite destination for tourists, but not so much the locals. Here we can find an example of free fall motion. Jump off a low dune, such as point 1, and then a high dune, such as point 2. Why does it feel like you hit the ground harder if you jump off the higher dune? Assuming that drag is negligible, when you jump off a sand dune, you are in free fall, meaning that gravity is the only force working on you. Acceleration due to gravity is negative 9.8 meters per second squared. The longer you're in the air, the longer you're accelerating due to gravity. This means that jumping from a higher dune means that you will be traveling faster right before you hit the ground. If you're traveling at a higher velocity right before you hit the ground, it will feel as though you hit the ground harder.